algebra. For 13, I'm going to give the solutions to the exercises in homework 6. So these was on page 100, number 1, parts A, B, C, G, H, and I, and problem 2 on page 107, numbers 1, 1, 2, and 3. So I'm not going to do all of these, but I'll do a good chunk of them. Okay. So on page 100, number 1, part A. Solve the following systems of linear equations by using elementary row operations to put the matrix into reduced echelon form and write the set of solutions as an affine subspace. So we have the pair of equations 9x minus 4y equals 1 minus 11x plus 5y equals 3. So the matrix of coefficients is 9 minus 4 minus 11, 5. And we augmented with the right-hand side, 1, 3. So we want this augmented matrix into reduced row echelon form. So I have a 1 here, so the second row fixed for the moment. Multiply the first row by a ninth, or equivalently divide by, you get 1 minus 4 over 9, 1 over 9. And then 1 minus 4 over 9, 1 over 9. I want to have 0 here. So I multiply this row by 11, and 11 minus 11 is 0. Minus 44 over 9 plus 5 is 1 over 9. 11 over 9 plus 3 is 27 over 9. 11 plus 27 is 30 over 9. When I'm all done, I have to check because it's easy to make mistakes, and everyone, including you, always makes some mistakes. Okay. I want to have a 1, so I multiply the second row by 9. So the first row is 1 minus 4 over 9 over 9. And if I multiply this row 9, I get 0, 1, 30, 38. And then I want to get 0 here. So I leave the second row alone. I multiply the second row by 4 ninths and add. 1 plus 0 is 1. Minus 4 ninths plus 4 ninths is 0. 1 ninth, see what's going to go in here? It's going to be 1 ninth plus 4 ninths times 38. What is that? Is that times 38? 4 8s are 32. 4 3s are 12. 152 over 9 plus 1 9. 153 over 9. 153 over 9 is actually an integer that goes in 17 times. I get 17 there. So this matrix is in reduced row echelon form, and this corresponds to the equations x equals 17, y equals 38. So let's just check this is correct. Plug this into the equations and it happens. 9 times 17 minus 4 times 38. Let's see, 9 times 17. 9 7s are 63, 153. 4 times 38, 4 8s are 32, minus 152. That's equal 1, so that checks. And the second equation, minus 11x plus 5y is, let's see, minus 11 times 17 is minus 187. 5 times 38, 5 8 40, 190. That's equal to 3. That also checks. So this is correct. This pair of equations is another set of two equations and two unknowns. They do part C, which is harder. At least it looks more complicated. Oh, sorry. And then the last part is write the set of solutions as an affine subspace. So that say L is the set of solutions. Well, there's just one. It's the vector 1738, which is you can think of as the affine subspace 1738 plus the subspace W, which is just 0. So one vector is always an affine subspace, a translate of the zero. So this is the solution space is an affine subspace, but a point always an affine subspace. Okay. Let's look at 1C. So here we have three equations and two unknowns. 6x minus y equals -3. 7x minus 2y equals 6. 8x minus 3y equals 15. Three equations, two variables. What is the augmented matrix? So the matrix coefficients, 6 minus 1, 7 minus 2, 8 minus 3, augmented by the right-hand side, -3, 6, 15. So you have to do a lot of arithmetic to put this matrix in reduced row echelon form. But if you have to do it, you have to do it. 7 minus 2, 6, 8 minus 3, 15. The last two rows don't change. We want a 1 here, so we divide the first by 6. You get 1 minus a 6 minus 3, 6, which is minus a half. So the first row starts with 1. I have the third row, but in the next step, I'm going to get a 0 here. So you take the second row minus 7 times the first row. 7 minus 7 is a 0. Minus 2 minus 7 times minus 6 is plus 7 over 6. So minus 2, 7 over 6, minus 5 over 6. Minus 7 halves, minus a half is plus 7 halves. 6 plus 7 halves is 19 halves. That's what we get. We want to get a 0 here. So 1 minus a 6 minus a half. 0 minus 5, 6, 19 over 2. I want to take the third row minus 8 times first row. So 8 minus 8 is 0. That's good. Minus 8 times minus 8 is 6. That's plus 8 over 6, which is 4/3. So this is minus 3 plus 4/3. That's minus 9/3 plus 4/3. I think minus thirds. Minus 8 times minus a half is 4. 15 plus 4 is 19. Okay, so that's it. I want to get a 0, a 1 here. So 1 minus a 6 my half. 0 minus 5/3, 19. Multiply this row by minus 6 over 5. I get 0, 1. And if I multiply this by minus 6 over 5, that's minus 57 over 5. If my arithmetic correctly. Not likely, but you never know. Okay. So the second row is row 1, 1. Minus 15 over 5. I want to get a 0 here, so I multiply this by a 6 and add. So 1 plus 0 is 1. minus a 6 plus 6 is 0. If I multiply this by 1/6, what do I get? 1/2 minus 50 over 5 times 1/6. Let's see, 3 goes into this 19 and into this 2. It's minus a half minus 19 over 10 is minus 5 minus 19. This is minus 24 over 10, or minus 12 over 5, if I did this correctly. You get a 0 here. I multiply this row by 5/3 and add. 0 plus 0 is 0. My 5/3 plus 5/3 is 0. If I multiply this by 5/3, the 5's cancel. Minus 57 over 3 is minus 19. Minus 19 plus 9. I get 0. Okay, wow. So this matrix is in reduced row echelon form. And this says that solution is x equals minus 12 over 5, y equals minus 57 over 5. Let's check. Hard to believe I didn't make a mistake, but you never know. So 6x minus y is times minus 12 over 5 minus 57 over 5. This is 6 times minus 12 minus 72 over 5 plus 57 over 5 is minus 15 over 5 is minus 3. Oh, what's it supposed to be? Lucky so far. Let's check the second equation. 7x minus 2y is 7 times minus 12 over 5 minus 57 over 5. 7 times 12 is 84. This is minus 80 over 5 plus 57 over 5. So 84 minus 57 is 7 minus 84 over 5 minus 57 over, so plus 57. So this is minus 27 over 5, which is definitely not 6. So this means I made a mistake somewhere. So all I can do is go back and check. So here I augmented matrix. 6 minus 3, 7 minus 2, 6, 8 minus 3, 15. So I multiply the first row by 6. So I get 1 minus a 6 minus a half. And this doesn't change. Then I subtract 7 times the first row, second row. So I get minus plus 7 over 6, which is minus 5 over 6. And 7 halves plus 6 is 7 halves plus 12 halves, 19 halves. So this looks okay. So minus 5, 6, 19 over 2, then, and 1 minus 6 is half. I take third row minus 8 times the first row. So 8 minus 8 over 6 is 4 over 3. So this is minus 3 plus 4/3. Minus 3 is minus 9/3 plus 4/3 is minus 5/3. That looks okay. And 15 plus 4 is 19. That looks okay. Then I multiply the second row by minus 6 over 5. So minus 6 over 5. That's minus 57 over 5. That looks okay. Then I add 5 times row 2 to row 3. So like 0, 0, and then 0. That looks good. And I take 5, and I take this row times 1/6, then I add. So I get 1, 0, 0, minus 50 over 5 times 6, minus 50, minus 5 halves. So minus 57 over 5 times 6 minus a half. So this is 2 is 19. So minus 90 over 10 minus 5 over 10 is minus 24 over 10, which is minus 12.5. So this should be correct. Let's see what we did here. 7x minus 2y, maybe I got the 2. That's 7 times minus 12 over 5 minus 2 times minus 57 over 5. Oh, okay, good. I just made a mistake in the check. So this is minus 4 over 5 plus 114 over 5, which is just 30 over 5, which is so that's correct. Good. So let me just check the left. 8x minus 3y is 8 times minus 12 over 5 minus 3 times 57 over 5. So this is minus 96 over 5 plus 171 over 5. 171 minus 96 is 75 over 5, which is 15. So this checks, and solution space is just a single point. One vector minus 12 over 5 minus 7 over 5. That's what it is. Ooh, good. A little bit of work, but that's the way it is sometimes. Let me do one more. Maybe I'll do part on. So this is exercise 1, part I. And in this case, set of 3 equations and 2 variables. This is 2 equations and 3 variables. X plus 2y plus 3z equals 10. 2x minus 3y plus 70 is minus 9. 2 equations and 3 variables. What is the augmented matrix? The matrix of coefficients of x, y, and z is 1, 2, 3, 2 minus 3, 7, and the right-hand side is 10 minus 9. So I want to put this in reduced row echelon. Well, I'm lucky there's a 1 already there, so I just have to make this a 0. So I don't change the first row yet. I take the second row minus twice the first row. 2 minus 2 is 0. Minus 3 minus 4 is minus 7. 7 minus is 1. Minus 9 minus 20 is minus 29. Okay. And I want this to be a 1. So I do this row by minus 7. So 0, 1. I don't know where that. This is 1 over minus 7, or minus 1 over 7. Minus 29 over minus 7 is 29 over 7. Okay. Then I want to get a 0 there. So I have to multiply, I take the first row minus twice the second. 1 minus 0 is 1. 2 minus 2 is 0. Multiply this by minus 2, like 2 sevens. 3 plus 2 sevens is 3 over 7. Multiply this by minus 2. I get minus 58 over 7. 10 is 70 over 7. So this is 70 minus 58. 7 minus 58 is 12 over 7. So if I did this correctly, This is now my matrix in reduced row echelon form. This entry is a 1, each non-zero row. 1 moves to the row, everything above and below the ones is a 0. This corresponds system of equations x plus 23 over 7 equals 12 over 7, y minus 1 over 7z equals 29 over 7. Or another way to write that is x is equal to 12 over 7 plus 20 minus 23 over 7z, and y is equal to 29 over 7 plus 1 over 7z, z equals z. So in the solution by z, x, y can be replaced with quantities. This is 12 over 7 minus 23 over 7z, 29 over 7 plus 1 over 7z, and z, which is exactly the vector 12 over 7, 29 over 7, 0, plus z times the vector minus 23 over 7, 1 over 7, 1. So if this is correct, the particular solution to these equations, and this is the general solution. So let's just check. What happens if I plug these numbers into the equations? X plus 2y plus 3z is 12z, 12 over 7 plus 2 times 29 over 7. This is 58. This is 70 over 7. That's 10, so that checks. And 2x minus 3y plus 7z. That's 2 times 12 over 7 minus 3, 29 over 7 plus 0. This is 24 minus 57 over 7. That's equal to minus 35 over 7, which is minus, oops, I did something wrong. 3 times 29 is 87. 87 minus 24 is minus 63 over 7. That is minus 9. So this checks. And so this is a particular solution to the system of inhomogeneous equations. This should be the general solution to the corresponding homogeneous system. So let's just check. If I plug in these numbers, I should get 0. Just to make it easier, if I factor out a 7, this would just be minus 23, 1, 7, and it's easier to work with digits. Let me just use the numbers minus 23, 1, 7. So x plus 2y plus 3z, this is minus 3 2 times 1 plus times 7 is minus 23 plus 23 is 0. That's, and if I plug into the second equation, 2x minus 3y plus 7z, that's 2 times minus 3 is 3 times 1 plus 7 to 7. This is minus 46 minus 3 plus 49 is minus 49 plus 49 is 0. So everything checks. So this is the general solution to this system of equations. And if I wanted to write it as a affine subspace, it would be the vector 12 7 29 over 7 0 plus the set of all scalar multiples of minus 23 1 7 any z. So this is the affine subspace. This is the subspace of R3. The solution to the system. Let's look at page 107. So on page 107, number 1, you have the matrix A, 3 minus 2, 2, 5, 7, 1, 0, and the vector X, which is 4 minus 1, 6. We compute A times X. So that's 3 minus 2, 5, 7, 1, 0, times 4 minus 1, 6. So I get 12 plus 2 plus 30, 28 minus 1 plus 0. So this is 14, this is 44, 27. 8 to X. This is a by 3 times a 3 by 1. That's a 2 by 1 or a two-dimensional vector. This is an R2. So we start with a vector R3, A times that vector. This is a vector in R2. What are the column vectors? 4 times 3, 7. Just take a vector and multiply it by scalar. You multiply every coordinate by the scalar. Minus 2, 1 is 2 minus 1. And 6 times 5, 0 is 30 times 0. So if I add these, 4 through 7 minus 2, 1, plus 6 times 5, 0, that's 12, 28, plus 2 minus 1, plus 30, 0. That's 12, 2, 44, 27, which is exactly what we got there. And this shows that this is AX. This is AX. So you take this vector, this matrix times this vector, you get a linear combination of the columns of the matrix. 4 times the first column, minus 1 times the second, and 6 times the third. That this calculation shows. And in problem 2, taking the same matrix and multiplying it by the transpose of the vector. If y is the vector minus 4, 9, that's a column vector, then y transpose, you change the column to a row. So instead of the column 4, 9, it's the row vector minus 4, 9. So y transpose times A is minus 4, 9 times matrix 3 minus 2, 5, 7, 1, 0. So this is a 1 by 2 vector or matrix. This is 2 by 3. So the product is going to 1 by 3, a three-dimensional row vector. So minus 4 times 3 is 12, minus 12, 60 through 3 minus 12 is 51. 8 plus 9 is 17. Minus 20, 0 is minus 20. So y transpose times A, this vector. And if I compute minus 4 times the first row and 9 times the second row, so minus 4 times first row is minus 4 times 3 minus 2, 5 is minus 12. Minus 8 minus 20, and 9 times the second row is 63, 9, 0. And if I add, I get 51, 17, minus 20. Just what I got over there, which simply demonstrates that when you multiply a row vector times a matrix. That's a certain linear combination of the rows of the matrix with the scalars by the coordinate of the row vector. That's what that shows. And just do the last problem 3. Again, this is on page 108. Number 3, we have matrix A, 1, 2, 3, 4, 5, 6, 7, 8, 9. And column vector X, 2 minus 3 minus 1. So to compute A, and this is just mixed multiplication, which you have to know how to do it correctly and efficiently and fast. So this is this matrix times this vector. You get 2 minus 4, more minus 3 is minus 7. 8 minus 15 is minus 6 is minus 13. 14 minus 24 is minus 9, minus 19. So if I did this correctly, this is what I got. But this should also be the same as 2 times first column minus 3 times the second column minus 1 times the third column. So let's check. 2 times this first column is 2, 8, 14. Minus 3 times the second column, this is 16, 15, 18. Minus the third column, 3, 6, 9. So I get 2 minus 9 is minus 7. 8 minus 21 is minus 13. 14 minus 27. 14 minus 13. No, 14 minus 27. 14 minus 18 minus 9. 14 minus 27 is minus 15. Let me see if I did this correctly. This is, you get third coordinate. It's 14 minus 24 minus 9. 14 minus 33. 33 minus 14 is minus 2. I have an arithmetic somewhere because here I got 15, here I got 19. So 2, 4, 7 minus 3 times 2, 5, 8. Oh, that's 2, 5, 8. That's the problem. My writing a bit. So this is 6 minus 15 minus 24. So 14 minus 24 is minus 10 minus 9 is minus 19. So that's okay. Okay. So that is homework 6. And we'll post the lecture with homework 7. Sure.